Hi viewers, this is Sri Ramlu. My YouTube channel is yes.yes space physics. So dear friends, before watching this video, please subscribe and share it. Now the today's topic is expression for Joule-Thomson cooling, right? So it is expression for Joule-Thomson cooling. So there is a derivation here. So please listen carefully. Consider consider a thermally insulated cylinder PQ divided into two parts by a porous plug G and fitted with the two non-conducting piston A and a B. Here consider a thermally insulated. So that is a thermally insulated means it cannot allow the heat energy from outside or into the inside. Okay, such a material we are taking here. Suppose the piston forces slowly 1 gram of mole of gas through the porous plug at constant pressure P1. Suppose if the piston what it is doing, it is a forces. So there is a diagram also. So this is a diagram. Okay. So it is a piston, A piston, it is a B piston. Okay. So it is a one side, it is P side and it is a Q side. When this piston is forces this side, what happens? The gas inside it its a pressure increases. Then it passes through the porous plug and enter into the second region. In this region it enters. Okay. Now the escaping gas pushes back the piston B subjected to smaller constant pressure P2. Here what happens? So when it is pressed in this direction, then what happens? The gas inside it compresses and its pressure increases. So increased pressure gas can enter into the this region, and this gas can apply the force on the piston to move in this direction. Okay, then its pressure what happens? Maintains a lower pressure, it maintains high pressure. So here gas is passing from low high pressure to low pressure through porous plug, then change in temperature will suffer. Let V1 and V2 be the volumes of gas before and after passing through the porous plug respectively. Here V1 is the volume of P1 side region and V2 is the volume of P2 side region. External work done on the gas by the piston is P1. So here it is a work done formula. Why it is work done? So we know that is what dW is equals to what PdV we know. Okay, so that means dW means small work. So that means simply work depends upon product of pressure and volume. Okay, so pressure and volume product gives what work done. So that is by PV P1 V1. So it is work done which side? This side. So work done, how does it works? Here piston is applying the force on the gas. So here work done by piston on the gas. External work done on the gas by the piston. Next, external work done by the gas on the piston. Here what happens? This compressed gas entering this side and this gas can apply a force on this piston, then piston moves this side. So here work done by the gas on the piston here, right? Work done by the gas on the piston. So that side work done is what? P2 V2. Pressure into volume gives work done. And their difference gives net amount of work done by the gas only. Okay. So let it is equation number 1. In addition to this, an amount of internal work done by the gas to pull its back molecules further apart against their mutual attraction. So not only work done by this inside the gas, and the gas also has addition extra work done to pull the molecules apart from mutual attraction. So inside the gas molecules may have the certain attraction. So to break their attraction, certain work has to done. Okay, so that work is also added here, and that work how can we calculate? Okay, so that breaking attraction work done, how can we calculate? So we can calculate as follows. See here, if we assume the gas to obey van der Waal equation, suppose that gas is obeying van der Waal equation, the attraction between the molecule is equivalent to internal pressure. Suppose the gas is obeying the van der Waal equation, then what attraction between the molecule is, what their attraction is equal to internal pressure. So that pressure is denoted by what? A by V square is the internal pressure. Okay, where A is a constant and V is the volume occupied by the gas. Here A is constant and V is volume. Okay, this is equals to what? Pressure. So pressure is what? Pressure is equals to internal pressure A by V square. Okay friends, now so it is a, now if it is a pressure in between the two molecules only. So molecules inside the gas contain the large number of molecules, then large number of pressure also present. So what I am doing, I am going to calculate now work done by all the gases. Here see, hence the internal work done against these forces when 1 gram mole expands from volume V1 to volume V2. Here this is a what? So it is a pressure, just now I told you it is a pressure into volume. What it gives? It gives to us work done. Am I right? So work done is pressure into volume. But here it is I am integrating volume V1 to V2. Okay. Suppose volume changes because of pressure from V1 to V2. Volume expands. V1 to V2. So V1 to V2 I have written here. And here see one thing. Here integration 1 by V square, 1 by x square integration is what? We know 1 by x square is minus 1 by x only. So that is why minus 1 by V I have written. But volumes where to where? V1 to V2. Substitute first V2 and then V1 and multiply minus. Then you get 1 by V1 minus V2. Actually what you get, you know, minus is outside, 1 by V2 minus 1 by V1 you get. Am I right? But if you multiply minus, so it become minus and it become plus. So plus term we have to write first and next minus term. So that is why V1 is first and V2 is second written because of this minus only. Thus the total work done W can be obtained by. So this is work done by the attraction and it is work done by the gas. So adding these two work, then we get total work done. So total work done. Okay friends, small disturbance. Okay, so total work done can be written as sum of above two works. So this one and this work done. So there's some I have taken, right? And from this write P1 V1 is equals. That means bring this whole side thing this side. Now it is a plus. If you bring this side, it becomes minus. So it is written minus. So W minus this one, W minus this one. Let it is equation number 3. Now according to van der Waal equation, so we have taken above van der Waal, it is obeying van der Waal only we have taken. So for this suppose according to van der Waal equation we have, so it is a van der Waal equation. Now multiply this P with this PV and this P with this minus PV, next with this 1V, V gets cancelled, A by V remains, next with this, then what? AB by V square RT we get. And here AB by V square both are having the mostly here two constants are there, so just remove it. So by neglecting it, what we get? So remaining thing we get, right? So it is equation, and from this bring this side, it is negative, it becomes positive, and it is positive, it becomes negative this side, and it is as it is written here only. So this is a formula. So to this formula what we have to do? First attach ones. For what? Only pressure and volume only. Here V1, here. Next attach 2's. Here 2, here 2, P2, here also V2. Okay, now see this. These are the like these two equations. First one's attached and next two's attached. It is a fourth equation and fifth equation. taking difference between the above two one. See their difference. So that means this minus this. So this minus this P2 V2 minus P1 V1. Okay. This minus this means first write this one and next write with bracket this one. Why? Because minus, for minus we have to use bracket. Now multiply the bracket here, minus inside. Open the bracket. It is minus. It is minus. It will become plus. Why? Because minus minus plus. So RT cancel. Next remaining thing. It is P2V to P2B and it is same thing written and it is also written same thing. This is also okay. Now take outside the common factor from this. Okay, common factors. What are the common factors? B common here. If you take B common, P2 minus P1. And here A common and write plus term first and next minus term. 1 by V1 minus 1 by V2. So this is. And next is what? Now bring this factor this side. Now this factor is minus plus. If you bring this side, it becomes minus. Is equals to this one as it is. Alright? Or sorry, not like this. Okay. It is not brought this side. What I did, so already P2 V2 minus P1 V1 I have calculated above. Where I have calculated above? See here. P2 V2 minus P1 V1 W minus this one I have calculated. So this formula is substituted in this place. So in this place it is substituted, right? From there I have taken this one. Next these are the similarly. What? Now it is minus term. If you bring this side, it becomes plus. Now it is these two terms are same. Then these two terms are added. So, but it is after addition written this side. Why? Because positive term numbers. And this negative number is there. Why? Because here P2 minus P1 into B. If we take minus outside, then what happens? P1 minus P2. So that is why minus taken this side. So it is let equation number 6. Since 1 by V1 and 1 by V2 are the small quantities, we can use approximate relation by using perfect gas relation for 1 mole of gas. So here to calculate these two things, what I am taking, perfect gas equation I am taking. 1 by V is there. So but it is for 1 mole PV is equals to RT. Now P bring this side. It becomes like this. Take their reciprocal. V 1 by V. RT by P becomes P by RT reciprocal. Okay. Now attach once here and here. Next two here and here. Then 1 by V1 is equals to P1 by RT. And next 1 by V2 is equals to P2 by RT. Okay. Now write these two formulas. 1 by V1 and 1 by V2. Where here and here substitute them. Okay. So here and here if you substitute, then what you get? Like this. From this RTs are taken outside common. Why? Because here RT we have. Okay, RT is taken outside. And from this bracket also we can take. Yes, bracket is also taken. W is equals to 2A by RT minus B, P1 minus P2. Now, as the system is thermally insulated, this work is drawn from the internal energy of the gas. Okay. When the system, above system is thermally insulated, then this work is we can where from we can take from internal energy of the gas only we can take this work. Okay, this work. Okay. Now for this what I am doing, hence gas cools. Let suppose gas is cooling. Cooling gas, how can we denote? Minus dt. dt is a small temperature. Minus dt is a small fall in temperature. Be the fall in temperature. If Cp be the specific heat at constant pressure, Cp is specific heat at constant pressure we know, then the amount of heat that must be supplied to restore the original temperature will be minus Cp dt. How we got this one? General formula is what? Cp is equals to dq by dt. It is the actual formula at constant pressure. From this dq is equals to what? Sometimes instead of dq we write du also, internal energy. So let me write du. Du is equals to what? Bring this dt this side, then Cp dt we get. So it is what internal energy is what Cp dt, but temperature is falling temperature is minus Cp dt. So that is why here minus Cp dt has come. The value, so it is in terms of calorie only. Calorie means it is a smaller unit. So in bigger unit, that is in joules. So we write Cp dt into joule. Okay, that means this work can be replaced. So du is internal energy is nothing but dw also, that is work done. So work done in the place, in this place what we can write, so this we can write. So that is why in the place of w minus cp dtj is written, and keep dt this side and the remaining factors bring this side. So what happens, this comes down and j also comes down, and instead of writing this is this side, so I have written this side and bracket is this side, but minus also comes. So like this, dt is equals to p1 minus p2 by cp into j 2a by rt minus b. This expression represent for cooling. Why? Because minus is there, so it is cooling equation. Okay friends, so watch this video again to understand. So if you listen it twice or thrice, then you can easily write in the examination without practicing it. So it is my humble request. Okay friends, don't forget it, this sharing this video to your friends also. Okay, thank you.